We're now going to look at definite integration. Definite integration is when you integrate an expression which has limits and you will get a numerical value. We can use definite integration to find the area enclosed by two curves. Now, when I say two curves, I don't strictly mean two curves. It could either be a horizontal line and a curve, a diagonal line and a curve, or two curves. So those are the only three scenarios then. Now, in order to find the area enclosed by two curves, we have a formula. And the formula is as follows. So it's area A, and that's equal to the integral, our integral sign. And then below the integral sign, we have a little limit A. And above it we have another limit B, and then in brackets we have top, close brackets, minus bottom. And then again we finish it off with our other integral symbol, dx. Now, what we need to do is work out what A and B are, what the top is and what the bottom is for the enclosed area here that we're trying to find. So on the next line down, we'll copy out our equals sign and our integral sign. A and B are the values of x that the area lies between, and the values of x are on the x-axis. So you go along your x-axis and you look for the two values of x that the area lies between. So you can clearly see that the area lies between an x value of -3 and an x value of 1. So the limits A and B are -3 and 1. A is the smaller limit, so we put -3 down first. And then B is the bigger limit, so we replace it with 1, 1 being the bigger one. Now, top, so we open up our brackets. Top means we're looking for the curve that lies directly above the area. So this is our area here. Directly above it is this line here, this horizontal line, which is the x-axis. Now, the x-axis has the equation y equals 0. So the top is given by the curve, and again I'm putting curve in inverted commas because it's not a curve, but the top is given by the curve y equals 0, which is our x-axis. The bottom is the curve that lies immediately below the area. So here's our area here. The curve that lies below the area is this curve here that's given in the question. So bottom is given by the curve y equals x squared plus x minus 6. Now, what we do is we replace the top and bottom with the non-y terms in each equation. So the non-y term in the top equation is just 0. So we just replace that with 0. Copy down our minus, open our brackets. And again, the bottom here is all the non-y terms in the bottom equation. So x squared plus x minus 6. Close our brackets and then copy down dx. So what we've done now is we've set up our equation which represents the area that we're trying to find. So it's now a matter of tidying it up. So again, we're going to copy down our equals and we're going to copy down our integral sign with the limits -3 and 1. We're going to multiply this bracket through by a negative here. So we're going to get minus x squared minus x plus 6. Remember, minus times minus plus 6 and then dx. So now we've got rid of the brackets, so we're ready to integrate. So we're going to integrate this expression. Because we're integrating with limits, we have to open square brackets. So we open square brackets and then we just integrate each term. So integrate the first term, add 1 to the power, divide by the new power. So we're going to have minus x cubed over 3. Integrate the second term, add 1 to the power, so it's going to be minus x squared. And then divide by the new power, 2. Then integrate a number term. Remember, you just stick x on immediately after it, so plus 6x. And remember, don't forget to add a constant, so we add on plus c. We then close the square brackets. Now, immediately outside the square brackets, we copy the limits down. So we put 1 at the top, and we put minus 3 at the bottom, immediately after the second square bracket. Now, what we do at this stage is we're going to break up this square bracket into 2 separate square brackets with a minus between them. So, I'm going to copy down another set of square brackets, put a minus down, and then open up another set of square brackets, like that. Now, the reason we've stuck 2 separate square brackets down is because we're going to sub the top limit into the expression inside the square bracket, and we're going to put that inside the first square bracket. We're then going to take the bottom limit and we're going to sub it into this square bracket, and then that result will go in the second set of brackets here. So, in the first set of brackets here, we're going to sub the top limit 1 into the expression in the square bracket. So we're going to get minus, copy down our minus, and then we've got 1 in brackets all cubed over 3. Minus, again, we're replacing x with 1, the top limit, so minus 1 all squared over 2, plus 6 times 1, plus c. We're now going to sub the bottom limit, x, remember the limits are x values, so we're going to sub the bottom limit minus 3 into the expression, and that is going to go into the second square bracket that we've opened here. So we're going to get minus, and then we're going to have minus 3 all cubed, that's all over 3, minus, and then we've got minus 3 all squared over 2, plus, we've got 6 times minus 3, and then we've got plus c. Okay, so what we're going to do now is tidy up each square bracket and get it into a single numerical value plus a constant. So 1 cubed is 1 over 3, so we're left with minus 1 over 3 here. Again, 1 squared is just 1, so don't forget about this minus. We're going to have minus 1 over 2. 6 times 1 is plus 6, plus c. Close that square bracket, copy down the minus, open up the second square bracket. Minus 3 cubed is going to give us minus 27, and then you're multiplying that by a minus, so that's all going to be a positive 27, and then divided by 3 is just going to give us positive 9. Minus 3 squared is going to give us 9, but then multiply by a minus, so you're going to get minus 9 over 2. 6 times minus 3 is minus 18, and then plus c. So what we're going to do now is tidy it up a bit further. So go to the first square bracket, you can use your calculator. So we've got minus a third and minus a half plus 6. So that's going to give us 31 over 6 plus c. Then copy down our minus. Open up our second square bracket, and again we've got 9, subtract 9 over 2, minus 18. and that's going to give us minus 27 over 2 plus c. Okay, next step then. We're going to multiply the second bracket through by a negative, and what you'll notice is the constants will cancel because we're going to have plus c here. Multiply this bracket by a negative, we're going to get negative c, so plus c, negative c's, the c's will always cancel. So we're just going to be left with 31 over 6, and then a minus multiplied by a minus will give us plus 27 over 2. And then go back to our calculator, 31 over 6 plus 27 over 2. And that's going to give you 56 over 3. And then if you hit your Shift SD button, that's going to turn it into an improper fraction, or sorry, a mixed fraction, which is going to be 18 2/3. And we've just worked out the area. That's what this numerical value represents, units squared. And that is how you find an area enclosed by two curves. And remember, it doesn't have to be two curves. It could be a horizontal line and a curve. It could be a diagonal line and a curve. It could also be just two curves.